Kia ora and welcome to this quick review of the first question from the 2013 Level 2 Probability exam. If there are any technical problems with this video, if you could leave me a comment, that would be great. I'm still getting used to how to make them. If you're having trouble seeing the exam questions, check that you've got your YouTube quality set to 720, not 480. Okay, so here comes the first part of question 1. We've got two teams, one from School A, one from School B, and they are in the final of a sports competition. They're taking part in a best-of-3 game series, and the game keeps going until one team has a winning score. The team that wins 2 games wins the competition, and really importantly, the teams are evenly matched. So we're asked to find the probability that Team A will win the competition at the end of the first 2 games. So we're going to use some notation that looks something like this. I'm going to do P bracket probability of A winning and then A winning again. So we can think about a tree diagram, but we don't actually have to draw the thing. So PAA is equal to 1/2 times 1/2. Right, so A will win if it wins both the first 2 games. So that's simply equal to 1/4. Okay, next part of the question, what's the probability that the winner can't be decided until 3 games have been played? So in this game, there are 2 things that could happen. The winner might be decided after 2 games, which would be the case if we had A win and then A win again, or B win and then B win again. So that would be 2 games. In all the other situations, it will take 3 games, because we could have A, then B, and then either A or B. We could have B, then A, and then A or B. So that means there are 2 ways to solve this problem. The easiest way is to say the probability that we need 3 games is just 1, take away the probability that we need 2 games. So this is the easiest way to work it out, because the probability that we need 2 games is just 1 minus the probability that A wins the first 2 or B wins the first 2. We've already seen that probability of AA is just 1/4. Similarly, the probability of BB is just 1/4. So our final answer is 1/2. Okay, the other way to work it out is to say directly the probability of 3 games comes from the probability of A, B, and then A, plus the probability of A, B, B, plus the probability of B, A, B, plus the probability of B, A, A. Now each of those is 1/8, 1/2 times 1/2 times 1/2. And they're all the same, so we can simply times that by 4, and we get 1/2. Okay, it will never go to 4 games. Okay, Bhavik wants to see if the team that has the game at their own school twice has an advantage. The first game's played at A, and the second at school B, and then back to A. So the probability of winning at your own school is 3/4. So he starts making a tree diagram, and it looks like this. So we're going to pop some extra numbers onto that tree. So we've got 3/4 here for when A plays at home. When we play the second game, the probability that A wins goes down to 1/4, 3/4 chance that B wins, and the same on these 2 branches of the tree. Right, and the third game, played at school A, well, the third game's only going to happen in these 4 situations that I'm drawing on. But again, if we put on A and B, we're back to playing at school A, so the probability that A wins again is 3/4, B is 1/4, A is 3/4, and B is 1/4. So we're asked to figure out the probability that school A wins the competition. So the probability that A wins comes from the following three things. PAA plus probability that A wins first and third, and the probability that A wins second and third. So working out these probabilities, we get 3/4 times 1/4 for the first one, plus 3/4 times 3/4 times 3/4 for the second one, and lastly for BAA we get 1/4 times 1/4 times 3/4. So if you look on the tree, I'm just going to go through that really slowly to make sure you've got it. A wins the first two, is that one there. A wins, then B wins, then A wins, is that one there. And the third one is what happens when B wins, then A must win the next two. Now when we add up those probabilities, I'm going to pop a new slide in to do that. You can use the fraction button, but we get this. So we're going to have 3/16 for the first one, plus 27 over 64, plus 3 over 64. So we want to get a common denominator, which will be 64. So we have 12 plus 27 plus 3, which is 42 over 64, which simplifies to give us 21 over 32, or 0.65625. I would prefer to leave that as a fraction, but either of those will be fine. Okay, next question. If Team A wins the competition, what's the probability that the winner would not have been decided until the end of the third game? So what we're looking at here is a conditional probability, the probability that it takes 3 games given that A wins. Okay, so we know the probability that A wins is 42 out of 64. And now on the top line, on the numerator, we're going to work out the probability that it has both of those two things happen, that it takes 3 games and A wins. So our first one is ABA, and our second one is BAA. Now notice that if you've done your working well for part 1, this is a really easy question. So we're left with 30 divided by 42, which simplifies to give us 5/7. Right, Bavig said that Team A is almost twice as likely to win the competition as Team B. Is his claim justified? Show your reasoning clearly. Well, we've got the probability that A wins is 42 out of 64, or 21 out of 32. The probability that B wins is 11 out of 32. So the probability that A wins divided by the probability that B wins is just 21 divided by 11, which is 1.91. So A is 1.191 times as likely to win as B, almost twice as likely. So we conclude, yes, his claim is justified. Now, that was an excellence question for this question of the 2013 paper. Next question. 3 games needed to be played to decide the winner of the competition. The first game is played at A, and then at B, and then at A. So we've already seen that structure, so that's what we're going to be working with here. The difference is that we're not told 3/4 and 1/4. We are told that the probability of winning at your own school is P. So we set up our tree again, like this. A, B, A, B, A, B. We only play a third game if it's gone one game to each school. So it should look like this. I'm going to put the probabilities on. Right. It is well worth taking the time to do a tree diagram like this. Okay, so we've got P, 1 minus P, and P, 1 minus P. So notice that the probabilities are reversed for the second batch of games because B is playing at home, so B has probability of P of winning. So we're asked to show the probability that A will win compared to B is given by P over 1 minus P. Okay, just be very careful to read up front that we're talking about 3 games need to be played. So the first thing we're going to find is the probability that A wins, given that it takes 3 games, is going to be probability of A, B, A plus the probability of B, A, A, okay, divided by the probability of 3 games. And the probability of B wins, given that it takes 3 games, is equal to the probability of B, A, B plus the probability of A, B, B over the probability that it takes 3 games. Now, we're asked to find the probability that Team A will win compared to the probability that Team B will win. So I'm going to insert a new slide here, so there might be a little glitch while I'm doing this, so just bear with me. Okay, all we're asked to do is to find one of those probabilities compared to the other. So we're working out the probability of A, B, A plus probability of B, A, A divided by the probability of B, A, B plus the probability of A, B, B. Right, notice that I've lost the denominator of having the probability that it takes 3 games because it is the same up here and down here. So it's simplified out. All we have to do is work out these probabilities. So the probability of ABA is equal to P times P times P plus 1 minus P, 1 minus P, and P divided by probability of BAB is going to be 1 minus P for A winning, and 1 minus P for B winning, plus probability of ABB is going to be P times P, 1 minus P. You might need to pause the video and just go back to the tree diagram, make sure that you can check each of those. So we're looking to end up with this. We're aiming to head towards P over 1 minus P. So it would be really nice if we could take some common factors out. That will leave me with this sitting out the front. And we can do that like this. So we get P into P squared plus 1 minus P squared on the numerator, and in the denominator I'm going to take out a common factor of 1 minus P, and here I have got 1 minus P squared plus P squared from here. Okay, so I can simplify by dividing the top and bottom by that, and I'm left with equals P over 1 minus P as required. Okay, the next 2 slides have just got the assessment schedule for you to have a look at. Hope that helped. As I said at the start, leave me any comments on things that weren't clear in the notes on YouTube. Thanks for watching.